38 plus 15 di by dt. di by dt. Here, if your question is 60, applying KVL 60 equal to 38 plus 15 di by dt. Our aim is to calculate voltage across inductor, voltage across resistor, I. These three values ni calculate share. Calculate I, voltage across inductor, voltage across resistor. Here, this is the voltage equation. Okay, applying KVL, write the voltage equation is 60 equal to 38 plus 15 di by dt. Here in the both the sides 60 equal to 30i plus 15 di by dt. So all the terms divide by 15 here, left hand side, right hand side, then we'll get 15, 1 5 di by dt plus 2y equal to 4. Then our aim is to, this is in the form of dx by det plus px equal to k, comma dx by dt plus px equal to k. Then equation is like this, dx by dt plus px equal to k. Then the formula is complementary function. Complementary function CF equal to C into e power minus px. Then particular function or particular integral equal to e power minus pt. Say here this here is e power minus here t here. The form is like this, e power minus pt. Here e power minus pt integral of k into e power pt into dt. Then next is after analyzing the expression dx by dt plus px equal to k form, our equation is di by dt plus 2i equal to 4. From this here p equal to 2, p equal to 2, k equal to 4. K equal to 4. Then our aim is to calculate complementary function, particular integral. CF equal to, C value is a constant, C into e power minus 2t. Then particular function equal to e power minus 2t e power minus 2t integral of 4 e power 2t dt over 4 e power 2t dt. Then after simplifying, e power minus 2t four is a constant, then 4 e power minus 2t, e power 2t integrate చేసాం, then we'll get e power 2t by 4, e power 2t by 2, sorry, e power 2t by 2. So this e power 2t, this e power minus 2t cancel out. Finally, here the value is 2. Why 2 means 2, 2 2 there. Cancel the, finally the particular function value is 2. Particular function value is 2. Then solution of equation I current I equal to CF plus TF then what is the value of CF? C into e power minus 2t, c into e power minus 2t plus this is equal to I. Then after calculating solution of a current, then our aim is to calculate C value. Then I have to substitute initial conditions. When switch is closed at t equal to 0 plus, which is very close to here, close to t equal to 0 plus. For this case, I equal to 0. Initial case, then switch is open or closed means I value equal to starting with the current value. So open case, starting this open means what is the current from here means I equal to 0. Then substitute t equal to 0, I equal to 0 in this equation. We'll get 0 equal to c into e power 0 plus 2. Then e power 0 value is 1. Then c equal to minus 2. C equal to minus 2. Then after calculating C value, substitute here. Then we'll get solution of equation I equal to minus 2 e power minus 2t plus 2. Then we'll get 2 is the common, 1 minus e power minus 2t. E power minus 2t. This is the current solution of first question. Okay. Next our aim is to calculate VR. What is VR? VR equal to I into R. VR equal to I into R. What is I? 2 into 1 minus e power minus 2t into what is the value of R? 30 ohm. 30. Then finally VR equal to 60 into 1 minus e power minus 2t. is the second question, VR value. Next, our aim is to calculate VL. VL equal to L di by dt. L di by dt. What is the value of L? So L is a constant we write here. D by dt of what is I? 2 into 1 minus e power minus 2t. E power minus 2t. Here 2 is a common. So 2 into L. 2L. 1 in differentiate is 0. 0 minus of minus 2 e power minus 2t. What will get with differentiation of e power minus 2t is minus 2 e power minus 2t. Then finally we'll get 2L minus of minus plus 2. Here means into 2 e power minus 2t. Finally, 4L e power minus 2t. So what is L value? 15. 15 into 4, 60 e power 60 e power minus 60 e power minus 2t. This is the value of voltage across inductor. 60 e power minus 2t. Okay, na? Is it clear? Hello?
Yes, sir.
Okay, ma. Then go for next. Next to RC circuit. DC response of RC circuit. DC response of RC circuit case, when switch is yes, switch is connected, R capacitance and connected to supply. Here V is the supply, R C. Yes, switch. Then this is the question, when current flowing through this loop here is I. That we are assuming that the current is I. Here capacitor and resistors are in series. Then our aim is to calculate solution of a current. Solution of a current for the given circuit. Solution of a current for the given circuit. If you are seeing here, write the KVL equation. If you are writing KVL equation, V equal to IR plus, what is the voltage across capacitor? 1 by C integral of I dt. 1 by C integral of I dt. Integral of I dt. Here in this equation, it consisting of integral term. Then our procedure is differential equation procedure. Then I have to first have to convert integral equation to differential equation. Then if what were to eliminate the integral equation, then our aim is to eliminate the integral equation by differentiating of all terms. Then we'll get the easy way to eliminate the integral. So differentiation of v, here v is a constant, right? Here v is a constant. V is a constant, differentiation constant differentiation 0 equal to r is a constant. I in differentiate చేస్తే di by dt di by dt plus 1 by c is a constant. So integral of I dt in differentiate చేస్తే then we get I. Integral of I dt in differentiate చేస్తే integral differentiation cancel out, finally I by c. Then this is the equation of a given RC circuit with DC response. Then this is in the form of r di by dt plus I by c. R di by dt plus I by c equal to 0. Then I am rearranging this expression di by dt by dt plus I by RC equal to 0. So if you are seeing this expression, is a homogeneous equation or non-homogeneous equation? The given expression
Homogeneous equation.
Homogeneous equation. No constant are equal to value or constant or sinusoidal signal. Then the equation is homogeneous equation. So if the equation consists only the homogeneous equation, then solution of a current equal to only complementary function, no particular function. Only complementary function, only complementary function, no particular integral or particular function. So I equal to complementary function. Then if the form is like this, di by dt plus I by RC equal to 0, then complementary function equal to c into e power minus pt. C into e power minus pt. What is p? P is 1 by RC. P is 1 by RC. 1 by RC. Then complementary function CF equal to C into e power minus 1 by RC into T. 1 by RC into T. Then solution of this is equal to current. Then our aim is to calculate C value. Calculate C value. Calculate C value. Then ఎలా చేస్తాం C value కి initial values substitute చేయాలి. Then how to substitute initial values here. And how to calculate what are the initial values here. If you are seeing at t equal to 0, at t equal to 0, at t equal to 0, so t equal to 0, here at t equal to 0 means initially the started case, switch is open. Switch is open means here, if you are seeing here, then resistance, it has some resistance is a dissipative element, capacitance is a charging element. at t equal to 0, since the capacitor never flows sudden changes in voltage. So here in this case, it acts as a short circuit. Here what you have here done here. So capacitor never flows sudden changes in voltage. Then automatically this capacitor it acts as a short circuit. When capacitor it acts as a short circuit, suddenly to close the switch, the capacitor acts as a short circuit. Then what is the current? It is short type I equal to V by R. At t equal to 0, then here in this case, I equal to V by R. I equal to V by R. I equal to V by R. So I equal to V by R. This is the initial conditions of when this is response of RC circuit. Why I equal to V by R means when switch is closed at t equal to 0, then suddenly this when switch is closed means the capacitor suddenly to short the circuit. Suddenly t equal to 0 short type then it acts as like this. For this case, capacitor short circuited, then what is the current flowing at t equal to 0 case? I equal to V by R. I equal to V by R. Then when t equal to 0, I equal to V by R. These initial conditions substitute here. V by R equal to C into e power minus 0 into t. So minus 0 into 1 by RC. Remember then e power 0 is 1. So RC that is equal to, so for this case, C equal to V by R. This value e power 0 value is 1, then C equal to V by R. The way to calculate the constant of C. After calculating C, then what next? C calculation then to solution of equation. Current I equal to V by R into e power minus 1 by RC t. See the solution of a current. V by R e power minus t by RC or e power minus 1 by RC into t. Here in this case, if you are seeing this, time constant of RC circuit tau equal to tau equal to RC. In time constant of RL circuit L by R. Time constant of RC circuit is RC. Then in terms of tau, I equal to V by R e power minus t by tau. Tau equal to RC. Then it means tau. V by R e power minus t by tau. Then if you are drawing the graph current versus time constant, that is tau RC value, time constant. I is on x-axis. Then the graph is like this. This value is V by R. Initially at t equal to 0, the value is V by R. Then goes on this exponentially decreasing. Certain time period, time equal to time constant degra, the value it reaches to equal to 0. This is 5. 1, 2, 3, 4, 5. Time constant. See the graph of time constant versus current. Then next is our aim is to calculate VR, voltage across resistor. What is the formula for voltage across resistor? I into R. I into R. That is equal to, what is the value of I? V by R into e power minus t by R into V by R e power minus 1 by RC into t. Then this R and cancel out. Finally, we'll get V into power minus 1 by RC into T. The formula for voltage across resistor. Next, voltage across capacitor. So voltage across capacitor is formula is 1 by C integral of I dt. So that is equal to 1 by C integral of I dt. I, what is the value of I? V by R e power minus 1 by RC or T by RC. T by RC into dt. See the voltage across capacitor. Here 1 by C is a constant. One by C is a constant. Here V by R also constant. So common, both V by R also common. Integral of e power minus T by RC. We all know that e power minus T by RC divided by minus minus 1 by RC. 1 by RC plus C. Plus C. After simplifying this, minus 1 by RC here V by RC, here 1 by RC. Finally, the RC cancel out here. Finally, RC cancel out. Finally, we'll get voltage across capacitor equal to minus V e power minus T by RC plus C. Here, this is the voltage across capacitor. Here, at t equal to 0, substitute, our aim is to calculate C value, then substitute initial condition. At t equal to 0, when t equal to 0 case, voltage across capacitor value also equal to 0. Voltage across capacitor value equal to 0. Voltage across capacitor, why the voltage across capacitor value? T equal to 0 means switch is open, switch is starting initially. Initially charging case, then what is the voltage appearing across here means the value equal to 0. Initially charged means then voltage across capacitor value equal to 0. Then substitute these two initial conditions, will get zero equal to minus V e power minus 0 by RC plus C. Then this e power 0, 1, then C equal to V. C equal to V. Then C equal to V. Substitute C value here. Then we'll get Vc equal to minus V e power minus T by RC plus V. Then both the terms, V is the common. V common is a 1 minus e power minus T by RC voltage across capacitor. This is about voltage across capacitor, DC response of RC circuit. V into 1 minus T by, so 1 minus e power minus T, 1 minus e power minus T by RC. So is it clear? Next, our aim is to calculate power in resistor PR. PR equal to PR into I. VR into I. What is the value of VR? V into e power minus 1 by RCT. I value is V by R into e power minus 1 by RCT. The product is the PR. Then similarly, power in the capacitor. PC equal to voltage across capacitor into, we know the VC value and I value, multiply this, we'll get the power in capacitor. This is about DC response of an RC circuit analysis. Next class we'll discuss problems related to DC response of RC circuit and then go for RLC circuit. Right, ma? Thank you.